Welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like. Today we're going to be doing a new kind of episode that we anticipate doing a lot more often. The idea here is that we're going to tackle one big idea, and Kevlin and I are going to do our best to debate this, I suppose, talk about our thinking on this issue, and hopefully come to some kind of conclusion on the question. So what's the question that we're going to talk about today, Kevlin?
Right. Well, it's a small one, Dave. Future programming languages. Just a little topic. And I think this is a really interesting one because it's one that developers often define themselves and their career, past and future in terms of the programming languages that they use. And typically there is a range. Sometimes people anchor around one language. Sometimes they have a range, sort of polyglot diversity to what they do, reflecting the kind of work that they do in their organizations. And it's always a question, what is the next big thing, whether it be 5, 10, or whatever years? And certainly there's a little extra pressure put on that question these days because of the role of AI, basically LLM-based code generation. But I'm going to suggest before we look at that, we look at what it is that we, both as individuals, developers, but also as organizations, what is it that we look for from a programming language? Why do we have programming languages before we understand what may be happening now and future trends?
Yeah, I think that's a great place to start. And I think that one of the things that often gets lost in the excitement around LLMs and AI assistants for coding in general is the idea that we'll be able to talk to them in natural language. And that seems like a poor idea to me, because the reason that we come up with computer languages, programming languages, is not because that's what a computer understands necessarily. It's because those are tools that allow us to be precise enough to instruct a computer what it needs to do. And that precision is something that's notably absent in human languages. We can be ambiguous, we can generate misunderstanding and all that. And that's exactly what we don't want with computer languages. We want to be exact and precise, because there's something fundamental about the level of detail that we need to express in order to be able to solve problems with a computer, it seems to me.
I think that's right, because what we're after is exactly that precision. And as you say, there's no ambiguity in a programming language. There's no ambiguity. There might be misunderstanding on the part of a reader, but there is no ambiguity. The expressions and the concepts are very well determined through language specifications and compilers. And in fact, people rely on that heavily. The idea is that what I look at today, if it appears to be the same as yesterday, then it has the same meaning. And in fact, more importantly, businesses rely on this. The business does not want an ambiguity appearing tomorrow because of an alternative natural language interpretation. And in fact, that, as you say, that this is, although we talk about programming languages as somehow related to computers, they're not. They are deeply, deeply disconnected. The level of even a language like C, for example, which is often considered to be low level, is actually so far above what a computer is doing that it would need binoculars to see what's actually happening. It runs in a very, very different universe. And the main reason that we think about these ideas and are attracted towards them is exactly that precision. And as well as a certain amount of conciseness, and then that idea of stability, that determinism, that what you are getting is a knowable and stable thing. And businesses depend on that very much. Which also explains another thing which I think is interesting, is that although we associate technology with rate of change and a rapid rate of change, there are certainly a growing diversity of programming languages. When you actually look at most programming languages, and particularly the popular ones, there is very little diversity there. They tend to cling around very well defined core concepts. These concepts have been around for decades. We often have paradigm wars where people say, there's a bit of a better way of expressing this and better way of expressing that. And often there is a point to be made. And yet the mainstream is incredibly slow moving. And when we look at the evolution of programming languages, we're now at a point which is quite interesting, where in 2025, most of the languages that people are using as they come into the industry, most of the languages they are using are actually older than they are.
Yeah.
There's a kind of millennial bump if we use human, Western social generations. There's a lot of languages from the 90s. There's a kind of one or two from the 2000s and early 2000s, and there's a few from pre 80s, and that was also true in the early 2000s. So what is kind of interesting is that the incumbent amount of code, there's a number of forces here. One is people's skills, one is the organizational investment, one is the existing code bases. They're not getting any smaller, they're not getting any younger. So we're not seeing, although we're seeing a lot of new languages being created, when we actually look at top 10 rankings and top 5 rankings, whether they are based on Stack Overflow questions, job adverts, GitHub representation, we're not seeing this rapid rate of change we associate with the industry.
Yeah.
We're actually seeing a huge bias towards the older languages.
I think that's a really important point, and I think there's often a kind of assumption that the hard part of learning to be a computer programmer is being able to operate in a programming language, and I don't think that's it. I agree with you that I suppose one way to frame that idea is that we are modifying the way that we think in order to be able to communicate with a computer. And that's not what a programming language is for. A programming language is about getting this precision so that we can communicate with one another, and it needs to be computable so that the computer can then do that work to get to the real low-level representation of bits, ons and offs and opcodes and things to really know what to do. And that's a very different kind of problem to the problem of a programming language, really, to express ideas and to chunk those ideas up. And that doesn't go away depending on, or at least that hasn't gone away so far. There is this seemingly very hard, durable problem of a level of detail that we must get to in order to be able to explore it. I remember during the earlier part of my career when 4GLs became popular, and the idea of being able to draw pictures and generate code from pictures. And it never really worked because it wasn't as good as text. It wasn't as expressive. It wasn't as flexible. It wasn't as version controllable, and all of those kinds of things that go around with the problem of programming and this ability to come back and fix things.
Yeah, I think that's exactly right. And to account for things, let's put it from that point of view. And as you say, text and textual notations have proven to be incredibly durable for this reason. That it turns out that whilst a diagram has value, normally the value of a diagram is in being able to show a point of view, but it is not necessarily in being able to be precise about everything. In fact, it's the very fact the reason I draw diagrams is so that I don't have to be complete about everything, so I can omit certain things. And there's stuff we can omit, certainly, and this is often where the paradigm wars come about, is that we value a certain brevity, and there's certainly a lot of boilerplate code, and I think some of the boilerplate code comes from each language does have a certain noise level, and there's other aspects in terms of library and framework design where you kind of sit there and think, well, why is this always there? Isn't the job of the library to take this code away? So there's certainly nudges and improvements we might invite there, but exactly as you say, that some of a condition is a condition. If we're talking about a business condition, you don't suddenly reduce it by using a 4GL. You still have to be incredibly precise about it. And it turns out that is the hard problem, if you like, that in software, although we might identify with languages as developers, the real skill is, as it were, technical adeptness and the ability to find that precision and to express it and to specify and to communicate it. That is genuinely the harder problem.
Absolutely. And I think one of the things that I suppose I'm slightly proud of, but I value in my own professional skills, is a kind of organized approach to problem solving. I'm quite good at solving problems when I don't know the answers, working through and trying to explore and find a way of coming at the problem from different directions and evaluating my solutions and all that kind of stuff. Over the years, I've picked up a variety of techniques, an awful lot of them to do with testing, to allow me to try and explore these sorts of things and find my way around. And that seems much more at the core of the skill of a programmer to me than necessarily adeptness with the latest, sexiest language or whatever. or any
Yeah.
language really. I think you can be a reduced. I consider myself a reduced instruction set programmer these days. I don't know every last bit of a programming language because I don't use all of it all of the time.
Yeah. And I think that idea, I mean, I love programming languages. I think the history is absolutely fascinating and I revel in that. But the idea is I don't think that is a necessary thing going forward. And we're actually seeing that
Yes.
reflected in terms of the rate of change. The language set, if you like, in the mainstream languages is very stable. People are
Yeah.
inventing new languages all the time, but there is a kind of an extreme curve here. This is there is a kind of a kind of like potentially even a power law
Yeah.
curve between the most widely used, the most popular, and the least. So there are most people probably know one or two languages that are novel or relatively
Yeah.
obscure and old. But most developers, the majority, you can normally pick 5 languages and you've covered most developers. And that
Yes.
is not to say that there is not innovation to be had, although, to be honest, there is relatively little innovation in the programming language space when you look back over
Yeah.
the decades. But what we're seeing is a stable core set. And what is likely to happen is that thanks to existing code, leaving aside the question of AI, thanks to existing code, that stable set just becomes more and more stable. But
Yeah.
we're also seeing within that people adopt, language designers and language communities adopt features from other languages. We're seeing a lot of
Yes.
cross-fertilization. So although they're not the same, there is a convergence in the feature set. You could probably, sort of add compare various languages at certain levels and say they've got very similar feature sets, although the feel of programming in them might be quite different. Lambdas in Python feel very different to lambdas and working with lambdas in Java because of the surrounding context and not simply a matter of syntax. But in terms of the shopping list, they are converging. So they're borrowing
Yeah.
from each other rather than developers moving off onto newer languages which perhaps are not supported by their organization, or perhaps they don't think are of value to know in future in terms of job security.
Yeah. So they're in many ways functionally they're less distinct from one another than we often give them credit for, and they're growing fatter as they
Yes.
accrete more and more of the ideas from everywhere else. So we're getting a more and more homogeneous set of behaviours in the language that are common and popular.
But to go back to your point, in terms of what are the skills, is obviously there's the ability to appreciate and master that at some level. But as you said, most of the skills are around the problem solving,
Yes.
around almost a skeptical approach
Yes.
to development. Is just like, did I really understand that? Is there only one way of doing it?
Yeah.
And how do I know I'm right? Which leads us to the space of testing and why
Yeah.
that idea of being able to precisely formulate, here's what I think I want. Let's
Yes.
build against that, and that leads to various workflows such as TDD. And
Yes.
that idea, I think, is the one of the durable ones, if you like.
Yeah.
That one is,
It's,
but it's an old idea, but it's not necessarily going to change the programming languages, but it is going to change our perspective on them.
yeah. And is durable. Whatever the nature of programming, probably whether humans are involved in it or not. But whatever the nature of it, it's going to be like that. It's going to be experimental and trial and error, and about falsification as much as it is about proof of things. Trying stuff out and seeing where it doesn't work. That seems like a fundamental of engineering and science to me. It's not going
Yeah.
away.
Yeah, and I think that idea of the falsification, I think is important because when we start bringing AI into the picture, then there are 2 elements where it's likely, well, 2 or 3 levels where it's likely to influence. One is clearly just being able to access knowledge about existing languages, both for tutorial purposes, but also for simple analysis purposes and code generation purposes.
Yeah.
There is a huge bias towards the existing training set, which is made up of, guess what, older languages, because there's a lot
Yeah.
more code out there. So there's a huge bias that is, I mean, I want to call it amplification, but it's actually it's kind of acting as a huge decelerator over across the board. Is that there's a natural tendency towards the majority and and a more conservative view in terms of the evolution of the set of languages, even some of their features as well. But
Yes.
then we've got the idea of how do I then prompt? The natural language is not normally enough. I've got an example where I actually spent 3 or 4 iterations nudging ChatGPT towards the conclusion that I want. because it's having the same problem with natural language that developers might do.
Yeah.
And so therefore, what we normally do is the idea of saying, well, okay, I want to be very precise. So let me tell you how I'm going to use English. And sometimes you end up with particular dialects that people will educate, almost DSLs for
Yeah.
LLMs, and say, here's how I'm going to use here's how I'm going to use language. I want you to do the boilerplate stuff. I want you to do this, but I want to
Yes.
be very precise about what this means.
And that seems to play very profoundly into what the future of programming might look like, because fundamentally what we are doing with a programming language, I suppose, is we at some level we are constraining the problem to a degree that we can get a viable outcome of some kind. And so when we have, natural language is not precise enough, it's not accurate enough, not detailed enough for us to be able to do that easily. So how do we communicate with an AI if it's involved in generating code in a way that can give us that precision and verify that it's doing what we tell it, because they lie to us. they mislead us. And so how do we do that? That seems like a big problem to me, and one that we're at danger of throwing away something very, very important, kind of fundamentally important in our ability to exert any control over programming if we don't take that into account.
I think that idea of control is important, because that's one of the reasons that we and organizations will invest, the value of a code base is in its precision. And people are very reluctant to change things. And you can actually see that when organizations are reluctant to migrate to newer versions of a language or a compiler, they're relatively conservative. An LLM is potentially this thing that is incredibly powerful, but its version changes invisibly on a day-to-day basis, and you can give it the same prompt and you get something else. So it's not enough to version control your prompts, but you've also got that idea of the business really doesn't like quiet changes to functionality. So how do we get this idea of something that is expressive and very, very powerful, but not necessarily 100% reliable in a way that we can determine? We're used to human unreliability. I mean, it turns out we have certain patterns to it. What we want is we want to avoid possibilities for things like supply chain attacks with hallucinated package names, which turns out to be a thing now. And so on the one hand, we might be able to get an LLM to generate and allow us to experiment with lots of alternatives. But at the same time, it opens up a set of things that perhaps we're not aware of. If we're only looking at the good things, we might be a little bit surprised about some of the downsides that are waiting there further down the line. And those may be just in terms of accidental technical debt that keeps pushing up, because we see that code quality is going to be is already an interesting question. The various stats suggest that LLMs allow us to generate more code. But it turns out more code was never the problem. It's the right code in a way that we can understand. And that's really the value. But what we're seeing is potentially people are adding code that has got more duplication, has got less extraction in terms of structure. And it's not to say you can't do these things, but you have to know as a developer, and this is where the skill set and the principles that we already know about come in, is you need to apply those. You've got to treat it as a conversation with an enthusiastic but not always reliable partner. But you also need to have that constraint. Do I know that it's achieving what I set out to achieve? So that bounces that back to, TDDs, precision of language, DSLs, the ubiquitous language of DDD. I mean, all of this makes it sound like we're in the early 2000s, but we've now got AI. But all the things that people were saying 20 years ago, you know what, you really ought to consider this. It's happening again. And I've seen people sort of say the skills that people will need are in these spaces. And in that sense, that's not news. It's just that people have rediscovered them, if you like.
There was a group of people there was a group of people some years ago that I came across that were talking about intentional programming. I think that's where maybe we ought to be going. We should be finding ways of expressing our intent and allowing the AIs to fulfill that intent. And as you say, that seems to me to be shouting out to us to apply some ideas that I know that you and I are very fond of. So building domain-specific languages based on the ubiquitous language of the problem that we're solving. So language that makes it easy to express concepts in our problem domain. Then expressing scenarios as specifications of what we want our software to achieve, our system to achieve. And then letting the AI fulfill those specifications. And then we can use those specifications as executable specifications, automated tests that verify that the specification is met. So we kind of stop writing in Java and start writing in DSL.
Yeah,
is maybe one possible future.
Yeah, that is definitely a possible future. But again, within that, we've got the idea that all of those skills that are often valued continue to be valued, and perhaps we do turn the dial up on them. Perhaps they're even more valuable than they were before, or more obviously valuable. In other words, there's more scenarios where if we don't attend to them, it'll come back to bite us more obviously. And I think that's definitely something that we are already beginning to see. But I think there's also that idea of remember who's in control. And what I mean by that is that determinism that you want is don't just version control your prompts and your choice, your DSL. You do still have to version control the thing that is generated. And perhaps the evolution of the thing that is generated, whether that is Python 4, let's imagine something, Python 4, Python 5, or Java 143 because its versions go up so fast. Whether it's that or C# 30, the idea is that you still need to version control the thing that is generated, and that's not like the assembler relationship we had in the past, which was at the machine level. It is still because that thing. In fact, it's probably even going to be more important that it doesn't change, that the language almost doesn't evolve, because we want to be absolutely certain of it, because that will be that kind of repository of determinism and ultimate truth. But it will also allow us to understand what's really going on when we make the requests. And so we are able to be accountable and repeatable, which I think is one of those things we want from an engineering perspective of this.
Yeah. So if I can sum up where I think we've got to, we think that the future of programming will be the past of programming. The core languages will be the same, with maybe some enhancement of features, but we're not finding new great ideas very quickly at that level. But the day-to-day job of a programmer will probably also involve the creation of application-specific, domain-specific languages that we can use to express these executable specifications, so that we can get incrementalism, so that we can grow our system in small steps, adding to the specifications and allowing the AIs to implement whatever it is that the specifications say we need to happen. So TDD and BDD are domain-driven design are the future of programming languages, maybe.
Yeah, welcome to the 2000s. And of course, that is just where we've ended up today. Yes. And you may have some other thoughts on this, because this is an open conversation that will run for many years. So let us know in the comments.
Please do. And if you have any suggestions for other big questions for members of the modern software engineering team to discuss, please do let us know also in the comments. Thank you, and bye-bye.
Cheers.